Right, mock exams aren't far away. So let's try a question a day. So let's zoom in so that you can see it. I hope that you can see it well. Okay. So first thing, we need to find the value of P. So we're told it's projected at a velocity we don't know, P and Q. We need to find what these are. But what do we know? We know that the horizontal is connected to I and the vertical is connected to J. So we can use that to our advantage because we know the horizontal distance is 57.6 meters. Okay, so we can just say S equals UT. So 57.6, and we know it hits the ground in 3 seconds, so therefore P has to be equal to 19.2. Just dividing it. Now, to show that Q equals 14.4, what we could do is S equals UT at a half AT squared. Because we know once it hits the ground, the displacement will be 0.9. The reason why it's 0.9 is because we are standing 0.9 meters above the ground. So if it hits the ground, it's gone down 0.9. We know that U is equal to Q, A is equal to 9.8, and it hits the ground in 3 seconds. So all we need to do is substitute that in, rearrange, and 3Q is equal to 43.2, so Q equals 14.4. So far so good. Now we need to find the initial speed. Well, we've got the horizontal speed, got the vertical speed. So all we need to do is do Pythagoras, okay? So 19.2 add 14.4 squared is equal to 24. Now to find the angle, the exact value of alpha, we need to compare. We know, let's say we say that this is the opposite, 14.4, and this is the adjacent. If we put 14.4 over 19.2, we get an exact fraction of 3 over 4. And we shouldn't use the tan inverse because we'll just get an angle. But the exact ratio is 3 to 4. 3 over 4, sorry. Now, we got a 6-mark question. And we need to find the length of the time the cricket ball is at least 4 meters above the ground. So this is going to be, again, we got to find the connection between the vertical and the horizontal. But let's work with what information we've given. So remember, we start 0.9 meters above the ground. So if we want to be 4 meters above the ground, we have to go another 3.1 meters up. So I'll say S equals 3.1. I'll take the upwards direction as positive. U equals 14.4. We calculated that from the previous question. If you remember, Q equals 14.4. Okay. A equals minus 9.8 because it's acting freely under gravity. And T equals T. Okay. So S equals UT at a half AT squared. So I can now form a quadratic and I get two solutions. T equals 0.23 and T equals 2.70. And these are the 2 points where T is above 4 meters, okay? So I just need to find the difference between these 2 points, and T equals 2.47. Right. Now, final part, we need to state additional physical factors which could refine the model. So things like air resistance, the ball not being modeled as a particle, us not taking into account wind speed. Any of these could have been acceptable answers. And really, the more questions you do, the more you'll see that it's usually one of these. Sometimes they might say other than air resistance. So, for example, the ball being modeled as a particle, wind speed, more accurate value of G. So, I hope that's made sense. Okay, 15-mark question. It was kind of long, but if there's anything confusing you, make sure that you go back through the textbook and do lots of practice, okay? That's the most important thing with these questions. It's just practice. And you'll see how repetitive these questions are over and over. Projectiles, they test the same concepts. They just change the numbers. So the more practice you do, the more comfortable you'll be in an unfamiliar environment. In the exam where there's pressure, you really want to make sure you feel comfortable. So I'll see you in the next video. Peace.